So I've been doing a series of videos on a laser shooting practice system, and I've done quite a few on it. I did a video on the sensor, which is right here. This call it an LDR, light dependent resistive sensor. And then I made a circuit board that amplifies that and controls this optocoupler, this optical isolator relay. And now I want to electronically be able to get the timing of that. And I was thinking about using an Arduino, but then it occurred to me, really I just need a stopwatch to start it and stop it. And so what I want to do, I've got this little electronic stopwatch here. I want to use an optocoupler like this. This is the PVG 612A. I want to have this optocoupler simulate pushing the start-stop button on the timer here. And that should be easy enough to do. I opened it up here. I've got the screws taken out already. Looking into the back of it, it's this switch here. And there's a little spring-loaded, like a membrane switch right here. You can see it and hear it. It's basically connecting this pad on the top to a pad on the bottom. I'll show you. Here's the pad on the bottom. And actually, all the pads on the bottom are together. They're all in parallel. So all I have to do is tie onto one of them at one point. I'll choose this little spot right here on the side. So I'll tie a wire here, and I'll solder a wire here on this point here, and I'm going to run the wires out the bottom here where the cord used to exit, and then I can just put a little connector on there and have it plug right into the board here, or later into a circuit. And then I can basically actuate this timer electronically with my circuit here to start and stop it. So I'm going to go now and prepare some wiring to solder on here. It's going to have to be some very fine wire. So what I decided to use is one of these servo extension cables that I had laying around. I'm just going to cut this off here and solder the white and the red onto this board and have this hanging out down here on the end. Okay, so I've got the board mounted in a vise here where I can solder onto it. And this is the point here I want to attach a wire to. And I'm using the servo extension because it already has a connector on the end. So I'm going to solder one wire right here on this via that's sticking up here. Shouldn't be that hard to do. First I'll get a little bit of solder started on it. And it might have some solder mask, so I'll probably need to scrape that away a little bit. And actually I'm going to try it here on this, where the pad is larger. Because that's such a fine connection, I'm afraid if I scrape it, I might break it. So I'm going to do it here where the pad is, the copper's kind of bigger. It might work. I've already got my wire pre-tinned. So I've got the red on there. I'm going to flip it over, and where I need to get to here now is this connection here. So I flip the board over now, in device. And now I want to attach this white wire where this pad connects. And I want to retain its functionality, so I'm not going to damage the pad, but I'm going to go off to the side over here and remove the coating so I can get the solder to stick right in this area here. It's a solder mask. So you just scrape it away until you can begin to see copper. Just very gently. And then once you can see copper, go ahead and try to get some solder to stick to it. Then once you can see the solder, the next step would be to set this wire down on it. And I kind of wish I had some tweezers. I think I'll have to go get some. Okay, so I've got some tweezers. So I can hold this wire on the trace. Of course, the wire is pre-tinned, so once I heat it up, it should flow. And I'm a little concerned about damaging the trace there. I could probably fix it, but I'd rather not have to. Let's see here. Looks like my LCD screen dropped off. I hope that's not a problem. Okay, I got the wires attached. Now I can just button this all together and hopefully get the screen to go back on there, and glad it didn't fall on the floor.